Thank you very much. This is going to be a very, very, very short talk because you're going to do the work. You just don't know it yet. So we have talked about a lot about green chemistry yesterday, today, and the day before yesterday. It's already day 3. Wow. So the idea now is that you apply your knowledge and that you are getting creative about generating new ideas or new proposals for problems that you might identify. Okay, we have seen that this does not work. There we go. So we have seen green chemistry in many, many, many different sectors in functional engineering, automotive, household, cosmetics, agriculture, electronics, pharmaceuticals. So it can really be applied in almost any industrial sector that you can imagine or that you're possibly even working on. And today or now, we want to invite you to think about sustainability and green chemistry yourself and how you can maybe include sustainable or green chemistry practices in your company, your organization, or your business model or your business need. How can you maybe improve an existing business model by using green chemistry? Or how you can contribute to sustainability within your organization, or how you can actually think about existing business models to make them greener or green. And also what your company or your organization would have to sacrifice to do such changes. So we have seen a couple of examples. For example, dyes here. We have seen that dyes can actually be made by fermentation of. Is that somebody's translating my language? Go on, please. So we have seen, for example, that dyes can be generated by fermentation using microorganisms, and they will generate actually colors in a much more benign way than chemical dyes. We have seen companies utilizing bio-inspired glues, like, for example, the one from the Blue Mussel, the catechol-based glue that is now utilized by many companies around the world for plywood. We have seen different pesticide companies. Vestaron is a pesticide company that actually uses peptides or generates pesticides. Or also we have seen bio-inspired materials like leather. Mycoworks is actually a company that does that kind of material. Fine Mycelium is the brand name of their leather. Or we also have seen the polylactic acid plastics. So I really don't want to take any more of your time, because what we are going to do is we are going to generate groups in this room, and the groups will sit together, and you will talk about what you're doing around the table, and you will identify one opportunity or one problem that you think could be solved by green chemistry, and you will develop that idea in your group. You will identify one person at your table that will be the speaker, the head of your table, and then you can actually generate a 5-minute pitch, and we'll give you 60 minutes to generate that idea. You can use, of course, your computers, you can use your creativity, and you can also create a pitch on the computer if you want, but you can also just freely talk about your idea. That's really up to you. You're completely free there, but we want that you get together and that you discuss green chemistry and that you think about the problems you might have in a company, in an organization, or in your university, a research project. You identify the one that all of you think has the best potential, and then you develop that idea. So to do that, it's really important that probably every table has at least one chemist. So all the chemists, raise your hands.
Oke, semua yang punya latar belakang chemist, boleh? Chemistry?
Oh,
Ya, boleh. Berapa orang? Maybe stand up
So
at the front first. Maybe boleh
yeah,
teman-teman.
maybe stand up. That's
Yeah,
easier.
stand up. It's easier. Teman-teman,
Chemical engineering is fine.
the fundamentals. Boleh Bapak Ibu yang punya latar belakang di kimia?
Oh, that's it. Okay.
I think chemist and chemical engineering.
Yeah,
Oh,
chemical
yes.
engineering is fine.
Chemist and chemical engineering. Bapak?
All right.
Pak,
So there's one table without
tunjuk tangan.
chemists.
Yes, one
So
chemist
maybe
at
some of
least.
the chemists can go over to that table. It's also one of the tables that has only 3
Yes.
people.
Nah, ini chemist semua kan? Nah, boleh didistribusi merata.
So we have that table in the
Yeah.
middle. Maybe 2 of you can go to that table.
Ya, 2 orang boleh.
And then also the table on the back there, no chemists.
Chemist semua ya? Oh, yeah, they're students. Yeah, students? Yeah.
Or maybe the students can just join
Yeah,
other
you can also
tables.
join. Yeah, this is a good experience. Boleh panitia juga sepertinya tadi banyak yang di luar, boleh masuk juga. Boleh ikut
So
masuk.
this table here has a
Ini
chemist,
udah
right?
chemist tuh dari Mbak Okti.
You're a chemist.
Ada lagi?
Great.
Oke, semua sudah ada chemistnya ya.
2,
Ini
3,
cuma berdua.
4, 5.
Ini udah this is too expert.
Maybe one of the students can join. Yeah, maybe you can join that
Please.
table.
You can join
And you
this
can
way.
join
Yeah,
that table.
I'm out of the team. I'm out of the team. Nah,
Okay, that's good actually.
silakan
1, 2,
Bu
3,
Liga.
4, 5. So
Ya,
we have 5 groups. That's great.
yes. Okay, so each table have 5 to 6 people. Itu 6 people boleh nambah satu di sini
Oh,
biar
there are more
sama-sama
people
5.
coming. Okay, we need to open another table.
Okay, yes. Boleh di sini aja?
That's fine. That's
Ya,
fine.
jadi 5-5 ya. Oke.
Yeah,
Masih
that
ada yang
table is
datang
great.
nggak apa-apa. Nanti latar belakangnya apa? Oh, kimia juga. Oh ya, boleh bergabung? I think 5 people per group is enough ya.
Yeah, 5
Yeah,
people
5
per group is
people
fine.
per group
So
is okay.
we can have one more table.
Mhm. Ada berapa orang yang belum kebagian? Bapak baru datang. Nah. Oke. Jadi coba masing-masing 5 orang aja. Boleh, Bapak boleh bergabung di sini. Ya, kita mau group discussion. Ini kayaknya kebanyakan orang. Boleh.
Yeah,
Ya,
maybe
boleh sini, ikut
one
sini.
person from that
Yes.
table and one from right.
Oh, Mbak Doni di sini. Baik, ini berenam. Masih berenam, boleh pindah ke sini. Yes. Nah,
Okay,
all
this
good.
looks good. Perfect.
Distributed, yes.
All right,
Yeah.
good.
Now we
So
have
everybody knows what we have to do.
5.
No, so we are going to form. Oh, all of the people on that table were not here. Okay, I will summarize them quickly.
Yeah.
So we are going to talk about problems or opportunities in your group around the table where you see the potential to utilize concepts from green chemistry or biomimicry to actually generate a new product or something like that. And you identify one person at your table who will be the speaker and present that that new product or new idea in the next pitching session in no more than 5 minutes. We will actually cut the microphone after 5 minutes. So if you're not done by 5 minutes, no market. And Audrey and I will be able and walk around. And if you have any questions, you can, of course, ask us. So everybody knows more or less what to do? Yeah?
So identify a problem first. What would you like to highlight? Maybe yang ada di perusahaan atau di di riset grup masing-masing gitu. Apa yang mau dibahas gitu? Ada problem apa? And then provide a solution also. Think about the solution.
Yes.
Yes.
The solution is
If there's a
actually
solution,
the
yeah.
solution is what you're going to pitch to us
Yeah.
in the second session. So we'll give
Anything.
you around 60 minutes, around 1 hour
Yeah.
to do sort of group discussions
Yeah.
and idea development
Yes.
and pitch development, of course. All
Okay.
right.
Yes. Okay. Okay. I think that's. This is 6 people. This is 4 people. One.
One over there. Yeah. Yeah. If you have any questions, we will be here.
Yeah.
You can ask us. We'll
Lars.
walk around and
Yeah.
we
Lars
can help
and
you.
Audrey will go around. Akan keliling kalau ada pertanyaan.
Yeah.
Yeah.
All the time.
Yes. 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 One problem per table. Mau bahas soal apapun bebas.
You can figure out the problem that you think is the most interesting.
The thing is already discussed. This is one more. Oh yeah. What? No. So whereas there are 6, no. Yeah, yeah, yeah. I think maybe first one. Soalnya orang pindah sini, soalnya ini cuma terkenal. Ini terkenal. Nah, ya udah. Ya, ya mana? Satu, dua, itu. Ini ya bukan lagi. Yang sudah tadi
Okay. Good afternoon, everyone. Welcome back to the session. So, as assigned in the schedule, we are now at the pitching session, and currently, only one group have submitted. So, I urge you to others to please submit your presentation as we are about to start the pitching session. Okay?
Just one thing, maybe
Yes.
that was voluntarily. You don't need a
Oh,
PowerPoint
yes.
presentation.
Okay.
If you feel more comfortable with
Oh, yeah.
presenting
Yeah. That is true.
presentation, you can also do that.
Yes. Okay. Okay. Mungkin gimana? Should we straight? Because one group has submitted. Maybe we start with that group.
Yeah.
Yes. Okay.
Who's that group?
Yeah. Ah, at the group, at the WhatsApp group. Yeah. Nah, grupnya Mbak Rona yang sudah submit. Boleh maju. Sudah komplit timnya? Come on. Yes. Okay. Complete. Okay. Group table 7. You can come to the stage. Yay. Please. So 5 minutes, yeah, for presentation.
Okay, you have 5 minutes.
Yes.
You will get a 2-minute warning and a 1-minute warning from here. And after the no investment.
Good afternoon, everyone. My name is Gabriela Kuswadi. I'm a student in Pertamina University, and I'm currently in my 3rd semester, and I'm majoring in chemical engineering. So this is the product that we've proposed. It's a biodegradable polymer for water treatment from green chemicals. That's the company that we are trying to improve. Yeah, silakan. Oh, pencet apa ini? Pencet. Oh, wow. So currently the product is a polymer, and we get the resource to make this polymer is from biomass, and the lifetime from their production until its degradation is up to 2 years. So the dosage that we're proposing, the dosage currently it's at 50 to 100 part per million, and the waste accumulation is 3,000 to 5,000 liters. And this is the part that we want to change, the waste accumulation, so that the waste at the end of the reaction, so this polymer will get mixed into the water treatment, and then reaction happens, and then precipitation occurs, and this precipitation is the one that is into the environment, and we want to reduce this waste accumulation. So the problem statements are: how do you reduce the waste accumulation, and how do you maintain the profits and the customers so that they still want to buy our products? So the solution is we want to design the polymer with a higher performance and a faster degradation, because when the performance is higher, then a smaller dosage is needed. And faster degradation means it prevents waste. So, like, for example, the polymer has a lifetime of 2 years, and then if we change the lifetime into 1 year, it degrades faster, and then the it biodegrades the waste itself is decomposed faster because the lifetime itself is shorter. Also, we offer not a product but a service instead. Why? Because if we offer products, then the customer would think, oh, after this product's lifetime has finished, then I would need to buy another product, and if it's finished, I would need another to buy another product. But instead, we propose a service, which means that this customer will sign a contract with us. So so, like, the customer will propose to us, I would like water of, for example, 98% purity. So we will try to maintain that standard using our own ways, which is by manipulating the concentration of the polymer, for example, or the lifetime of the polymer. Yeah, I think that's. Please correct me if I'm wrong. I think that's it. Thank you. Oh, we have another slide. Oh, I'm so sorry. so these so these are of all the 12 points of the green chemistry principles that are involved, we highlight in one, which is waste prevention, the four, designing benign chemicals, which is part of the waste degradation methods, and the use of renewable feedstocks, because our feedstock is from the biomass, and design for degradation. I think that's all, I hope. Okay. Thank you.
Cool.
Wait,
Thank you. Can we
discussion,
ask
right?
questions?
Yes. Okay, maybe to make it more fun, all the team come at at the front. Yeah. Yes.
Team photo.
Yes. Yes. Ayo, boleh. Soalnya now it's a discussion. Supaya masuk ke kamera juga ya, Pak. Boleh ke depan. Now Q&A and discussion. Silakan, Bapak Ibu.
Yes. The
Have you considered which feedstock you would like to use to make your polymer?
biomass, from biomass.
What kind of biomass?
Okay.
uh, the renewable feedstock that we will use is the third generation of the biomass. That means it will come from algae. Uh, algae? Yeah, algae. Yeah, the third.
Indonesian algae.
Indonesian.
Okay, cool. I really like your approach that you addressed not only the green chemistry principles, but also chemical leasing. So when you're thinking about the service of cleaning water, you're only thinking about the purity you have to hit, or you're thinking about the volume of cleaned water that you want to sell? Because that might also be another approach. And did you think about what's better for your business model?
Thank you.
Our investment will depend on the answer of this question.
Whether the volume or the
Or purity.
volume or purity. Okay. So we are trying to position ourselves in the perspective of the customers. Of course, what they would like is to have a guarantee of the water quality after treatment with the product itself. But yeah, since so we see that as by selling as a service, then they don't really have to care about those technical things about green chemistry. They might just release their own technical teams, let go of their technical teams, and leave everything to us, for example, like that.
Okay. So I'm sorry. I didn't realize that it had started. So I'm going to ask, I won't ask a question that you've addressed in your presentation. So you're using a biodegradable plastic to treat water. But what is the value of that material to be biodegradable?
What is the value?
Because you're okay, so how so yeah, this is several questions in one. I realize I'm going to try to simplify that. So when you design a biodegradable plastic, is because you want to make sure that when it goes to the environment, it biodegrades, right? But at the end of your process, you have a polymer that will contain some toxic compounds. What do you want to do with that? And what's the value of this being biodegradable then?
Okay, we have to tell the story. So this is actually a real
Yeah.
Okay, so the beginning of the idea starts from an actual product of this gentleman's company.
Yeah.
So there are a lot of secrecies
Okay.
that cannot be disclosed. But the thing is that they have already been using renewable feedstocks in the beginning for their
Yeah.
products.
Yeah.
Yeah, but on the yeah, it's going to end up.
But you could
You
have
mean?
called this bio-based polymer.
Hmm.
You decided to call this biodegradable polymer. So my question is exactly there. I understand why you want to make your sourcing biomass. I think that makes a lot of sense. But my question is, why do you want to make it biodegradable? And you don't need to reveal any trade secrets here. This is really like concept question.
Okay. I try to answer your question, Miss. So it's biodegradable or biomass? Bio-based, yeah. That's actually biodegradable because why we say biodegradable because it's in on the side actually like example in the mining sector our product is time by the time is uh, uh there's a changing of the color. There's the changing of the color inside the product until the how's it mendekati approaching the expire of the product. So we could conclude that the product is there is a contain of biodegradable contain. Yeah.
Okay. Can I what is it? Perbaiki? Elaborate. So after hearing his answer once again, I realized it's actually not a biodegradable polymer exactly. But if we are keeping this title, so that means our polymer will be can be degraded by enzyme or bacteria. That means we have to make another treatment eventually by adding some enzyme, for example, or for a bacteria.
But imagine that at the end of your water treatment, you have your material contains toxic metals.
Yeah.
Are you gonna throw this in the compost?
So our product will not contain a toxic metals. It
But you're
will,
cleaning water. What are you cleaning water from?
oh, the water. Oh yeah, because it's chelate by the polymer, for example, right?
Exactly, because
Yeah.
you're gonna use it in the mining sector, so it's
Okay.
gonna be full of some metals, whatever.
Uh,
You
no, the one in mining
yeah, exactly. So that's my point. Yeah.
this one is in mining industry as well.
Yeah, it's a coal.
Okay. Uh, let's try this. What if we
Yeah, so this is what I want. I would like to. This is why I made.
okay. There are several options. The first one, we need some filter.
Yeah.
Some filter, then we can separate the sediment of our complex metal
Yeah.
from the purified water.
Okay.
The first one is that. The second one, we can recover our sediment. For example, this is an absurd idea, but let's say we add some properties to the polymer, like magnetic properties.
Mhm.
That way, we can collect
Yeah.
the sediment
Yeah.
without removing the water from
Yeah.
the
Yeah.
container.
Yeah.
I think
Yeah,
that's
that's a
two
good idea.
ideas.
That's a good idea. But my advice to you is that maybe what you want to do, especially if you start to engineer it, is make it non-biodegradable. Because you don't want it to start to degrade while this is working, right?
Okay.
Maybe you want to you want to spend a lot of time making something that's durable so that you can indeed recover it and reuse it multiple times. So my advice would be bio-based, yes, biodegradable. You have to convince me that it will make sense.
Okay.
What you could think about is putting your polymer, your bio-based polymer, into sort of a column and pump the wastewater through the column and make it sort of continuous flow
Continuous
water
flow of the
filtration
water.
until it's full, and then you change it. You can maybe recover it. You can wash it, and then you can recover the polymer and wash out the metals. Yeah, no, then it should only be bio-based. The biodegradation could be an option if you broke down the polymer in a high concentration, giving a high concentration brine or something like that.
Yeah, exactly. So there are cases where in water treatment you want to make stuff biodegradable when there is a chance that the thing will come out. So for instance, chitosan is thought as a good replacement for flocculants because if in the process of the water treatment there's a flash flood and your sewage gets out of the facility, then your flocculant will go with it and it's okay because it's biodegradable.
Yeah.
So I think the question that I was asking is more geared towards what's your design so that you can justify that biodegradability makes sense. So my recommendation for the future is think about your design so that you can justify all the properties of your material. Remember, function is key.
Oh yeah. Okay. Thank you.
Well done.
Thank you very much.
Okay, fantastic. Thank you. The first group for the presentation is a bit like a dissertation, isn't it? Prepared in 1 hour and then pitching straight away. Okay, berikutnya ada sudah masuk semua grupnya? Number 4. Thank you. Grup 4. Yes, your network is your siapa ini? Ibu Mita, Ibu Noni, Ibu Rizka, Ibu Desi dan Raja. Kami persilakan untuk maju. lima-limanya boleh maju, boleh dong. Ya, silakan. Kelompok 4, boleh tepuk tangannya? Yuh. Oh, oh presentasi dulu Pak Raja, habis itu lanjut satu tim.
Thank you. So yes, good afternoon. As I'm the minority in the table, oh sorry, I'm the only man in the table, so I have to be the one who present this one. So it will be a bit different to the previous. Oh, excuse me. It will be a bit different to the previous group because we came from different backgrounds, like chemical engineering and chemistry, ecology. So it's a bit difficult for us to wrap in one thing. So we agreed on pitching our idea as an incubator. So we will become incubator for business based on technology and science. And what? So we start from this one. All of us, 5 of us in our table, we face the same problems. Ibu Mita, for example, and then Ibu Noni and the others, and me as well. When we have ideas and we make our a prototype, we always uh, told that, are you crazy? Why are you making this one? It doesn't make money, and etc. etc. So this is the problem, the hard problem that we are facing. So like, just buy something from abroad and sell it again and you get money. And then we did a little bit research, and then our research budget is only 0.2% of our GDP. That's why it's tough for us here. And then Ibu Mita says it, even for her, it's really tough, the regulations to create something out of something. She needs something from abroad, and then regulations strict them. And then again, Ibu Noni also, well, we discussed a lot. Like Indonesians spend almost 8 hours per day in the internet, and almost 3 hours 14 minutes per day in front of online social media. So that's our what we discussed, the problems. So what we learned from Professor Moore's presentations and also last presentations is, I think there's something wrong. The limit of your world is your language. I think government, us, scientists, people, they have their own language. So I think we will touch upon this issue. So we have to be what, why. So this is the problem, our why. So bridging and networking. So this is our pitch to you. We want to become a group that bridge people through science, through networks. So we learned a lot about networks from your presentations, like all about networks. So, and I remember personally, I remember in 1973 there was this paper published. I was not born even yet. It's called "The Strength of the Weak Ties." It's only proven. It's only proved only in 2000-ish, when computer science is, when computer power is becoming more powerful. So weak ties is very strong actually. So weak ties, what is weak ties? Me and Ibu Noni, me and Ibu Mita are weak ties. We don't call each other every day, but we know each other and we can make something together by bridging. So our idea is to bridge and to network. To bridge and network. If you can't explain an idea to an 8-year-old, you don't understand it. It's Richard Feynman, by the way. So we agree that we have to become what we want is, so it's our how we bridge, we network, but what we want is to make science communicator. We want to make as many science communicators as possible. This is our original manuscript from our table. So, and we love this lady, Jen Goodall, by the way. Uh, she's amazing. She's an amazing scientist, but also an amazing science communicator. So this is our pitch. We want to make science communicators more and more in Indonesia, and channel this one into the, decision makers. And we will close with quotes. We love quotes. To go fast, go alone. To go far, go together. Thank you very much. So, oh, stay. Help me, help me. I'm gonna be grilled. Help me.
Oke, boleh silakan naik ke atas ya. Kita lanjut sesi diskusi.
See,
Tidak boleh
I'm the minority. Okay. So everybody can see. Oh, sorry, what? Oh, sebelah sini. Yes.
Okay. Thank you. I loved many of your pictures and quotes, but it won't open my checkbook very easily. First, I thought this was for green chemistry ideas, but I didn't capture that in the presentation. So that was the first. Is there a relation uh, in your accelerator?
Yes. You wanna
For green chemistry, right?
Yes.
Yeah.
Yeah, this is actually people when they hear about the word of green chemistry itself, they're already afraid. Why? Because they think there's about the stoichiometry and then about the reaction, and they afraid of that. But if we have the kind of the science communicator, yeah, it will be easy because green chemistry actually in our everyday life. Yeah, it's very near to us. So this is a one kind of how to approach of the green chemistry itself. Yeah, by the science communicator.
Okay. Okay. And okay. There are several accelerators and incubators already in Indonesia. And I guess the difference is that yours is largely focused on content creation for science communication. Yeah. So, but why an incubator and not, say, a multimedia company that makes content?
Excellent. So why? Think first that the number that we presented to you before, that Indonesians consume multimedia like crazy, hell crazy, like number two in the world after the Filipinos, I think. So we agree that we enter from that one first. We enter from that one, but of course, on our backyard, we prepare the incubators. That's what we are currently doing with Ibu Mita, actually, with the University of Pertamina. We have 10 Ibu Mita, or we have 10 startups from University of Pertamina that we are trying to really bring it up and then go to market. That's our answer.
What's the percentage you get from each company that you assist?
Not a businessman. Share-nya mau jangan.
And how much do you want for your punchline? Your network is your net worth. I really like that. If you help the companies communicate, you should get a fair share of it.
Yeah, because we are science. So about it.
But okay, and what's your revenue? Where do you get money? How do you get money? How do you pay your employees?
We think of getting like what Lars asked. We think of getting the percentage from the shares, but we have to think really.
Can't you get as well a part of the, if when you're a YouTuber, you get paid
Ah,
from a share of the publicity, the ads that come on your show, right? So can you also generate revenue from your followership that way?
yes, actually, we can, but I don't know
Thank
among.
you, jury member, for giving you the answer, right?
You can answer with your Instagram account.
Yeah, it depends on the followers. Yeah, but sometimes 50,000, 50 billion. Berapa sih? Dolar. Oh, dolar berapa sih? Tiga ribu. Tiga ribu. Dolar. Yeah, around 30. Sorry, $3,000. Yeah, per month. It's usually it's not the higher level of the it's the low in the middle.
I have full confidence you guys are gonna get huge followership in TikTok with your team. So I don't have any doubt about the fact you can raise them.
The students over here who's a digital creator.
We have the
Oh,
talent here.
fantastic. Very good.
Has
Congratulations.
8,000 followers.
Hey.
Why don't you share your Instagram? Sorry. Yes. She shares about science. Science creator, yeah, digital creator, content creator.
Because Indonesia is very few of the TikTokers or YouTubers focus on science. Maybe we can count by fingers. Yeah.
So I see a strong and balanced team here. There's a lot of potential. Thank you.
Yeah, you can check like my friend Phil Jessup, who's been doing the same role as me in Jordan last week. He's got some videos on TikTok as well that are really good about green chemistry. So you can follow him and maybe also get some inspirations.
Maybe I can add something. We also think of combining this with art. So like dancing your science, or well, there's something called dancing your PhD, right? So like you can dance your dissertation. So we are thinking of combining this with art, music, science. So this what we have in mind. Yeah, that's all. Thank you.
Thank you so much.
Thank you.
Okay, thank you. Next, we would like to invite Group 6. Is everyone on board? Group 6? Meja 6. Benar ya? Yes. Boleh silakan maju ke depan. No worries. No worries.
I know it's really cool. She's very young.
Yeah, I wanna have it framed
I
in my
know.
office. I totally want to have it framed in my office. It's so beautiful. There's so many different ways. Okay, I'm representative from table 6. So maybe here we want to share like 3 ideas. Yeah. Uh, the first one is we uh get the idea from the process in our the lady over there with the pink hijab from Lautan Otsuka Chemicals. Yeah. So this company is manufacturer of the blowing agent. So the material like urea, natrium hydroxide, chlorine, hydrazine hydra, and many additives. The product is the blowing agent, and what we want to uh, focusing here is process itself, because the process is using the reactor, which using the heating and while stirring, and the process needs to be controlled with the temperature of the process. Uh, Depends on the end product. The temperature of the process is between 50 degrees to 120 degrees Celsius. So the source of the energy, the heating currently used in the company is the electricity from the PLN. Yeah, and there are 2 types of boiler also. The one using the coal, and the other one using the solar fuel. So the idea is to use the green chemistry with the principle, then maybe it's the renewable feedstock. One is to change the electricity from the LN by using or utilize the solar panel. Yeah, and for the boiler, change from the coal or the solar fuel using the natural gas or the steam. So with this we can maybe reduce the emission. Yeah, and maybe the other thinking we can also explore by using again the steam that produce. Maybe we can how to say it? to maybe we cool down and become the water again, and we can use it to produce the steam again to be using in the next process for the heating. So that one is the first case from Lautan Otsuka, and the other two maybe is from, because two of us is from the paint and coating industry. So the next is we want to focus on the solvent using. So like, yes. 2 minutes. Oh, 2 minutes. Okay. The idea is to the solvent in the process we use the solvent as the cleaning. So the idea is to use the recycled solvent. So it will be separate into the solvent and the sludge. The solvent is we can use again in the production or in the cleaning for the next process, and the sludge maybe we can burn it using incinerator, and maybe we can dispose it, but the waste that we dispose is much lesser than the original. So the third one, we have still 1 minute. Okay. So the other one is like the TSR technology for the architectural paint. The idea is to the total solar reflectance. So the paint will reflect the heat from the solar, the UV resistance. So the temperature inside the room will be lesser. So it will become the energy efficiency. So the temperature of the cooler, the air conditioner, will be lesser than without the TSR technology. So that is from table 6. Thank you.
Session, discussion. Okay. Please, to all the members of the group to come on stage. Yes.
So which one of your projects do you prefer us to analyze further, to ask you questions on, 1, 2, or 3?
Number 1.
Yeah, which one is your like number one, the one that you work the most on?
The first one?
Yes, the first one.
Okay, I have a question then.
Go ahead.
Did you calculate the energy need and the need for solar panels that you would have to acquire to substitute your energy supply in the plant?
No, because for that we have to get the data. Yeah, so we're asking the employee here how many the waste they use, but it takes time to contact with the person in charge in the company, so we cannot give the data, but maybe we can calculate, yeah, from the data if we received it.
So what is your number one challenge, you think, in establishing this transformation? What will be the most difficult part? What do you think?
I think the investment, yeah. Or at least
Be brave. Be brave. Come on. Pick up the mic. Let's do it. Yeah, you got it. You grab it. It's good. Yeah, yeah.
Okay.
Yeah, nice. Good work.
Bahasa Indonesia ya.
Yeah. Yeah, Indonesian is fine.
I'm sorry, I can speak English.
Okay, it's okay.
Untuk di LOC sendiri, kita mungkin untuk renewable energinya ya. Jadi kita akan mereplace apa namanya, boiler solar dan boiler
Okay.
batu bara
Okay.
untuk menurunkan apa sih emisi gas CO itu. Jadi kita pakai natural gas, natural
Okay.
boiler itu, natural gas boiler. Nah itu kita memang akan dilakukan mulai di tahun 2024.
Mhm.
Dan semuanya itu akan berganti selesai semua di 2028.
Cuman kita masih proses gitu. Challenge-nya itu kita memang harus stakeholder dulu sih, kayak misalnya kita harus menjelaskan, terus apa ya, company gitu, investasi. Emang yang paling besar itu investasi challenge.
Oke, berarti dari segi penyediaan energinya ya dalam operasi itu sekarang masih pakai batu bara gitu ya. Nah, terus sekarang lagi mau transisi ke boiler gas. Okay, so what she's saying is in her company right now for energy providing, they're using still coal and they are trying to make the transition to natural gas. But one of the obstacle is finding the investors for the transition. So that's what she is saying. Ya itu ya. Jadi apa masalah providing the energy ya to conduct the transition energy. Yeah. And then mencari investornya atau meyakinkan to convince the investors ya how they are going to conduct the transition energy. Yes. Apa?
I think what she mean is to how to make the management agree to the investment. So maybe they have to calculate the pro and cons to implement that changing.
Okay. Nice work asking a question. I hear a lot from scientists that they need more data and they can't do anything until they get more data. But a lot of decisions are being made while we're waiting for more data. So, have you considered any approaches to move forward without data, or to perhaps simulate data, or how can you start to get moving without waiting for information?
Ya biasanya kan kendalanya ada yang mau langsung menjawab? Ya. Apa? Oh ya, jadi apa yang disampaikan Matt itu kan biasanya kita butuh nunggu data dulu gitu ya. Tapi kan pada kenyataannya kan kita harus gimana ya tanpa kita menunggu data, jadi nggak nunggu-nungguan. Gimana kita bisa mulai transisi tanpa ada data real gitu ya. Itu sembari dikumpulkan, tapi bagaimana bisa apa ya bisa tadi ya terkait transisi tapi tanpa ada data sebelumnya gitu. Apakah dengan simulasi atau mungkin bisa gimana? Ya, bantu terjemahin saya, Bel. Boleh pakai ini, nanti saya bantu terjemahkan. Iya biar kedengeran. Gak apa-apa, soalnya kan
Gimana ya kalau untuk data ya?
kalau nggak ada data, tadi yang Matt bilang kalau nggak ada tanpa data, apakah bisa bergerak gitu? Gitu. Bisa bergerak nggak gitu kalau tanpa ada data dulu gitu?
Bergerak tanpa ada data.
Atau mungkin bisa ambil skenario dari perusahaan lain mungkin yang sudah mengimplementasikan gitu. Jadi bisa menggunakan itu sebagai study gitu kan ya, jadi dasarnya. Nah,
Udah mau jalan ya.
oh sudah jalan.
Jalan ini kita lagi proses pembangunan lagi.
Lagi proses pembangunan. Berarti udah teryakinkan atau gimana?
Sudah.
Oh sudah.
Cuman makanya kan tadi kita memang dari perusahaan sudah mulai berkomitmen. Awalnya memang belum kan, cuma sekarang sudah berkomitmen dan sekarang lagi proses pembangunan dan akan terrealisasi untuk bertahap dulu kita dari boiler solar dulu yang dirubah, terus baru nanti batu bara kayak gitu.
Oke.
Ke situ karena kita emang target untuk mengurangi emisi CO2.
Sudah terbangun berarti. Oh, sudah. Oh, so they've already have the infrastructure actually. So the transition itself is already happening. Yeah. And right now you are in the progress. Yeah. So okay. And the target is in 2028. You've already transitioned to gas. Yeah, for the energy consumption. Yes. Okay. Yeah. Okay. Yes, thank you. Okay, so the next group, table 5. This is a privilege. We'll be the last because one person is not here, right? Yeah, yeah. So group 5, come on. Yay. Ayo. Ayo Bapak Ibu, silakan. Ayo, monggo.
Okay. Uh, Good morning, everyone. Okay. I I want all of you feel like morning too, right? Okay. Did everyone know this one? What is it? You know it? Ah, good. Okay, you can get your prize from committee, right? Okay. We start with this one. So, uh, we will talk about propylene. Okay. My team, I am Yanuar and Manda and Bu sini nggak ada. Oh, oke. Pak Daryanto, Mbak Okti, Wendy. Oke. Oke. Okay, why we uh in focus for propylene? Uh, at the first, we start with our brother working at the Nippon Sukubei Indonesia. Uh, so Nippon Sukubei produce SAP or super absorbent polymer, and this company is never lose because this company only one in Indonesia. Okay, and they supply all thing. You know, SAP. SAP usually let's say popok apa ya Pampers. You know the gel. Yes, diapers. Usually you can find if you have a baby or the old one, so you can. Okay, and then the Nippon Sukubai need about 170,000 a year for the propylene for produce SAP. And then, you know, in Indonesia, it's about 1.2 million in a year for overall and mostly supplied by the company name is Chandra Asri in Cilegon. And all product propylene is coming from naphtha, you know. So the naphtha is the fossil fuel, right? And almost all imported from outside. Oh, Middle East. Okay. 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 Good. So then our idea is want to replace the problem coming from naphtha going to the bio yeah bio propylene. Okay, so researching that the propylene can produce from the biomass in Indonesia that we can find is from this one from ethanol. We can produce from ethanol, so we can find many ethanol in Indonesia. Ethanol is coming from usually produced by molasses. Molasses is okay. One more slide. So the ethanol is side product of the molasses in the sugar refinery. So we can use it to produce the propylene. Then second is glycerol. Okay, okay. Glycerol is from the bio what's that biofuel, biodiesel. So this one is the side product also. So we can produce propylene from this one. Okay, that is enough. Thank you so much.
And please, I invite the rest of the group. Oh, there's the next slide. There's one more slide, they say. Yeah.
Okay, sorry. Okay, you got it.
Going.
Okay, so I know you are not sleeping, right? Okay, so we can find in the 12 method for Please, 12 principle in green chemistry, we can know that the number one, number two, and nine plus and seven. Okay, thank you so much.
Oke, thank you. Oke, ya tadi boleh Bapak Ibu sekalian yang dari grup yang sama, kita siap untuk diskusinya. Kami persilahkan.
Okay. A great idea. I like it. It's one specific, it's a good lesson for the other teams, right? One specific reaction, one specific molecule. It's nice work. You mentioned there's only one company making this in Indonesia, correct?
Correct. Correct.
How will they feel if you come and try to take their market share?
No problems because so our plan is cooperate with them. So one is the all method, not the bio, and the new one side by side is bio. Right?
Okay, living in harmony.
Yes, living in harmony.
Okay. And what particular source of glycerol are you going to use, and how do you know that? Like, where is it coming from, or have you thought about this?
Palm.
Yeah. Eventually, in Indonesia, we have a regulation to use biodiesel in our diesel for our diesel engine. For now, it is about 40% must be replaced with biodiesel. I mean, if you go to the gas station, if you buy the biodiesel, if you buy the diesel fuel there, it will be 40. It will contain 40% of biodiesel and 60% of petrol diesel. It is a mixture of it, and it is a compulsory in Indonesia. That's why Indonesia is producing our own biodiesel up until now. And as the palm oil producing country, we only synthesize the biodiesel from palm oil, which is RBDPO.
Yes.
And the uh, big side product of the biodiesel industry is, of course, the glycerol.
Okay. I'm nervous you're going to fall off. Yeah. Okay. So there's an assumption that palm oil production will continue to grow, whereas we know there's a lot of unintended consequences, such as deforestation and other types of environmental impacts. So I would just challenge you to make sure that you don't choose a feedstock that may actually decrease over time, right? Because I think the biggest question that the company is going to ask is, what are the unit economics? How much does it cost to produce 1 kilogram of palm oil derived versus buying it from fossil? So if your feedstock decreases potentially because there's a regulation that tries to regenerate the rainforest and there's less palm oil, that's going to make your product even more expensive. So I would encourage you to be flexible in the source of your glycerol as well.
Yeah, maybe there's we need to add. I think eventually in Indonesia there is also a regulation for not opening new land for palm oil plantation, oil palm plantation actually. But yeah, you know, if there's somewhere else is open, it must be illegal. That's why our government is actually underline that we need to intensify the land that we already use for palm oil plantation, not opening the new one. That is the idea. That's why the deforestation is actually it's it's not an issue anymore if everyone uh, follow this rule. follow these regulations actually. And also, anyway, we also give the alternative for for the resources, the renewable resources for the propellant production actually from bioethanol, which is generated from molasses. In Indonesia, we also rich in sugarcane plantation, and it is a very good resources. Thank you.
Can I maybe ask about the vision of your venture towards the biodegradability of materials? Because polypropylene, of course, is a non-degradable thing. Do you have any comment on that? Any vision and any vision of what kind of resources to use to maybe step into that arena?
Oh, we actually discussed before about this, but later uh, thought that this was not our okay, our focus this time. So we like opted the discussion like that, and then apa ya?
So because we do not know the solution yet, we focus on not if we cannot do the biodegradable things, we do the renewable source. So that's what we thought in our discussion.
So I'm going to ask a friendly question because I know the answer because you mentioned that to me another time. So, how about the global competition? Other people are making biopropylene out there. What is the advantage of your Indonesia based biopropylene on the global market?
We actually hard, I mean, difficult for us to how can I say, to fulfill our needs. So I don't think we need to export.
So who was telling me yesterday or the day before that biopropylene from Germany costs 4 times the cost of. You were telling me that. Yeah, you were telling me that, right? Yeah, yeah. So that's the answer, right?
Yeah. Yeah, frankly speaking, this is based on our uh, target for the net zero emission that we targeted on 2030 to reduce 30% from the baseline. That's why one of our roadmap is by this changing the raw material from the fossil based to the bio based. This is the
And right now you can't do it because of the cost. Am I correct? Right now you cannot buy biopropylene because it's cost prohibitive.
Yes.
Yes.
And also with the market, so the SAP bio based SAP is not belum not needed, still not needed by the customer. So just from the promotion or just from the increase the company value, but not from the as the needed from the bio
Okay.
SAP.
So your customers are not yet ready to buy that. Is that correct?
Yes.
Okay. Okay. Yeah. Maybe you should not have said that at this point in the exercise. But I appreciate your honesty. Yeah. Yeah. Exactly.
Okay.
Or I mean, or if they manage to make the biopropylene cost effective because it's based in Indonesia, maybe then your customers will be interested.
Yeah. I think our opinion is like that's why we want to not eliminate the all company, just both of this company with the new marketing strategy, right?
Mhm.
So the sub production is still the customer still the demand is big, yeah. So maybe we can divide it to into
two markets.
yes, two market.
And have you thought about your subsidiary in Japan? Because Japan is a market where there might be an opportunity for bio-based superabsorbent polymers. So that's another approach
Yes.
potentially.
Yes.
Because you're working with a Japanese you're
Yes,
working with
maybe. And then for SAP is right now is we just sell for the like we say pampers, yeah. Yes, diapers, sorry. Diapers, but we can use for another apa ya, a purpose, right? For the agriculture or something. So there is many thing that we can
I think there's room for bio-based diapers in the Japanese market.
okay.
They will like it.
Yeah, I think it's catchy, but anyway.
Okay. Yes. Okay, thank you.
Thank you so much. Well
Okay.
done.
Okay, so last but not least, group table 3. Silakan, Bapak. Ayo, Pak. Apa? Oh, sudah. Okay, so I'm not supposed to be in the group, but because they were talking about what we were going to pick. So here we are talking about preventing silica scaling in a geothermal power plant. Okay, so next slide, please. Okay, so geothermal energy. So geothermal energy, as we maybe some of you haven't heard about geothermal energy. So geothermal energy is practically we are producing heat, we're producing steams right from the subsurface, and Indonesia itself is one of the largest country that has the potential. So from the Ministry of Energy and Resources, we have around 23 gigawatts available in Indonesia. Because of our geological condition, we are in the ring of fire. But currently, up to 2024, we are only producing 2.3 gigawatts. So this is the map of Indonesia, and this is what a geothermal power plant looks like in the setting. Okay, next. And this is, but again, despite all its goodness, because it's a renewable energy and has less emission compared to fossil, they also have several problems when we are producing geothermal, because what we extract is not pure steam or hot water or brine. There is also additional minerals that comes with the production of steam. As you can see, there are sulfide deposition, calcite deposition, and then there is silica. And as you can see, that's not a pretty picture inside of your pipes when you're producing the geothermal fluid. So this is an issue, one of an issue in developing geothermal power plant. And what we would like to highlight in our team is how do we handle the silica deposition? We are trying to mitigate to prevent for the silica to deposit in our facility. Okay. So as you can see, the cost is this is we try to make an approach of how much it would cost. So it depends again on the quality of the fluid. The cost itself, it can reach up to $26,000 per 5 kilometers to replace the piping from the geothermal wells up to the geothermal facility, power plant facility. And then I'll give next to Pak Rian because I'm not a chemist. Okay.
Thank you. So this is the mechanism of the scaling, especially silica, because we concern about silica so much in this process. So we talk about silica mechanism of formation. So we have like curve or formation. It depends on two variable: the silica level itself and 2 minutes. Okay, silica level itself and also water temperature. So we control the temperature, and also we silica level is given from the earth itself. So we control the temperature there. So we will see which region that the complexity of the silica scaling itself on site. So, and this is the silica inhibition mechanism. Yeah, uh, we categorize as maybe four. We do the stabilization of the oversaturated silicic acid, and then we do the crystal growth modification. We do nucleation inhibition, and we do the sequestration or chelating mechanism. So I think this is four of the scale silica inhibitor works, and we see from the mechanism. Yeah. Okay. So the current chemistry of the silica inhibitor itself is phosphonate or organophosphate like phosphonate, PBDC, AMP, HEDP, HEDP, etc. And this is the existing chemistry of the silica inhibitor in the market. So here we would like to make it more green. This is our homework with the team, how to make it more green from the existing silica inhibitor. So this is the mechanism of the magnesium given from the liquid or fluid, and then the silicate. So we prevent by this is the example of the phosphonate ACTMB. So so yeah, the chemistry of the green antiscalant will be provided by Pak Yudis and Bu Raisa. So please welcome, and Bu Menteri maybe.
Time is up.
You can have 30 seconds.
So ADPF, we can degrade it again with the photolysis degradation and using CO2, CS4, etc. and reduce the AGPA uh, and we can change also with another alendric acids can soluble in water, so it can degrade also being antiscalant. So their degradable antiscalant can be the number 1 and 3 for the 12th principle of green chemistry. Maybe can still research, yeah, many side effects from this. And thank you. The question, please.
So you presented different antiscalants. You presented the phosphonates and then other structures. Can you comment a little bit on the advantages of each of them in terms of green chemistry? You seem to say that the legacy ones were less green, but the new one, I'm not really sure, have a very different formula. So I am not sure I completely get what's the greenness of each of these solutions?
Where? Next slide. Yeah, this is we need the like the sunlight degradation with basically photolysis, and we need to analyze this, yeah, the degradation process with because this is still research and it had already happened, yeah, and we need to optimize the intensity of the light and also the distance and also the time of the degradation. Before that, we need to assuring the silica can bring coordination, yeah, like complexity with the magnesium and the HDPE. What's the name? HTPM. There are many ligand we can we can optimize, and the condition pH, like equilibrium coefficient, also we need to optimize. And after that, the ligand can be degraded, and the rest residue just magnesium silicate, and can we uh, solve with acid or base like that. And
Okay,
then
'cause
another we can change with
yeah.
another
So what would be
phosphate.
the advantage of this one?
This one,
Alendron
the
alendronic
solubility
acid.
more available, more uh, um, the solubility in water is very high. Yeah.
Okay, gotcha.
Then this HTPM.
Okay. So this degrades into ammonium salts and phosphates. So this has a high potential for eutrophication.
Yeah, for
So
nitrification.
can you comment on that?
The comment about the how to degrade it.
No, so if it degrades, that's nice,
Yeah.
but then it degrades into things that have high potential for eutrophication. So is there a risk that you're gonna have algae blooms, or if this
Oh,
gets
it
to the environment?
can happen because in the pipes there are several plankton or another when we image in in ocean like that, or so it can be the meat nutrients for the algae or bacteria like that.
So is there an opportunity to couple that with collecting silica, which we know is actually a really important mineral
Yes.
in rice culture in particular,
Yeah.
and turn your waste for this is waste for your process, right?
Yes,
In a way,
waste of
but turn this into a resource for making fertilizers.
Yeah, no fertilizer. This is a different type of fertilizer, like a soil conditioner. We call it soil conditioner because many resources come up from the smelter, from the steel process, like the flow by Kataposco. They produce a huge of byproduct of the silica, and now we try to make a standard for this soil conditioner. The same thing. The same thing with this.
This is just idea in Scale Lab, yeah. Already published, but I don't know in industry.
Still, this is just on the research, not become commercial yet.
Maybe just a question on other chemical structures that could fulfill the same the same purpose, because as Audrey already said, these don't look too bio-based or biodegradable per se. So did you look into maybe naturally occurring phosphoric acid that you could maybe use as a descaling agent?
Depends on the chemical here, is available or not in nature. Normally, we must synthesize, and then because there are many electron donor, yeah, electron donor to make a complexity with the silice and magnesium. So this is we cannot apa ya, avoid, yeah.
Any questions from the money guy?
How about
So I know the magnesium silicates are a problem for other geothermal wells, not just in Indonesia. And there's a variety of existing solutions on the market, right? And so I guess how does this compare to the others? I know there's already other types of acids that are used, and often you might have to do multiple applications. So when you compare it to something like a mechanical scraper or something like this, it could be far more expensive. So do you believe that this is will eventually be at cost parity or above? Will it ever be more affordable than the existing solutions? Or what is the main driver of someone to adopt this over the variety of existing commercially available solutions?
Okay, so this is we were discussing, is it prevention or is it mitigation, and we're talking about preventing. So the one that we see before at the picture, that is already happening. So silica is deposit in the pipes. So what we want to is we inject the acid. Yeah, we inject the acid inside of the geothermal well, inside of the inside of the pipe, so it won't deposit. So preventing them to happen. So it's coming. Yes. Maybe from the injection, maybe from an injection well. So there has to be a yes, because in geothermal there is production well and injection well. So we were thinking about putting injection, so it comes inside the reservoir, and then we can produce a less concentration of silica. Yeah, so it's preventing. Yeah. Yes, high temperature and
Yeah.
pressure.
Quick question for you. Is it just so I understand, is it a closed looped system? So is your fluid
No, sir. Because sometimes when we inject, it's not always totally comes back inside the reservoir, right? Because we have to understand the rock characteristics. We need to
I
understand the
understand.
permeability
Yeah,
and
yeah,
everything.
yeah.
But the concept in geothermal is we try to maintain for the system to be sustainable.
Okay,
Yeah.
so that you
Yep.
inject as little water as possible. So the idea is that most of the water will be equipped with this acid,
Yeah.
will run through
the facility,
the
yeah, the power
facility,
plant.
and then if there's a little bit of water seeping out, it will biodegrade based on your systems. But then if it seeps out, it's mostly inside the earth, not on the ground.
Well, not all the production fluid is injected back. So not all the fluid is injected. It's not like one production well, one injection well. It's not like that, the concept. It's about the heat and mass balance. So the mass, because there is also natural recharging. So, but because we are making a different in the system, that's
yeah.
why we have to have an effort of re-injection.
Okay, I
So,
understand. So
yeah.
I mean, I'm trying to understand the water that contains that descaling agent.
Yes. It's still
Where is it going to come out in the environment? Is it going to come out on the ground, on in the sea? Is it going to come out far from the location of your plant? Is it just going to stay inside the rocks?
Okay.
Do you know?
Yeah.
I think
Normally,
that's
it's still in the rocks,
Yeah.
but after exiting the turbine, the condenser, there will be some fluid existing in the environment, and then there is also water treatment before we release it to the environment.
Okay.
Yes.
Because that could be an opportunity for you to recover any of it if you
Yeah.
wanted to.
Oh, yeah, and
then
reuse
use
them.
it. Yeah,
Yes.
and then use them for soil improver, whatever. Okay, got you.
Okay.
Thank you.
All done? Okay. Yes. Well done. Okay. Okay, so now I'm back again, not representing the team. Okay, jadi kita sudah selesai untuk pitchingnya. We finished with the pitching, and that is the last session of our green chemistry training for today. Would you like to say a word? Yes, to close the session. Yes.
Yeah, absolutely. We're gonna totally close the session. Yeah, we were
can do it.
starting to
We can do it.
invest in your company.
Oh, we won the pitch that mean. The pitching. Oh, see, we won the pitch.
Yeah, don't listen to him.
So, economist.
It's gonna rob you.
Oh, real. Oh, the idea.
It's gonna
Ah.
rob you. Don't listen to him.
Percentage, yeah?
Don't trust this man.
Okay,
Don't trust this man.
okay. Please.
So, well, I just wanted to thank everybody for your wonderful work. I think we've heard about an incredible variety of topics here, going all the way from geothermal, which involves some physicist friends here, and we heard about ideas around education, ideas around energy, around chemicals, around blowing agents. We have a huge variety of people here who have presented fantastic work. So I just would like to really give you guys a big round of applause for fantastic work. So it's been a huge pleasure having this day with you. For me, it's been wonderful because we've been talking a lot, but now we hear from you. And now you see how difficult it is to answer questions, right? Right? Exactly, exactly. Especially not in your field, which is exactly how we feel when you ask questions. So I guess that we're just gonna close the day today, and thank you so much for being here today. Tomorrow we'll start again here at 9.
Yes, that's
And
right.
tomorrow is Matt's show, so you'd better come because that's gonna be funny, right? We're gonna
All
all
business.
business.
Okay.
It's gonna be money. Yeah.
Everyone likes money. Everyone can correlate.
I leave the floor to you. Thank you so much again for a wonderful day.
Thank you, Audrey. Okay. Terima kasih semuanya atas apa namanya pitching and discussion session. It was really fun ya. Now it's the other way around. Okay, jadi kita tutup sesi hari ini. Besok kita tomorrow we will be back here at 9 ya. Correct? Yes, at 9 again to continue. But because this is my last day for this, for the green chemistry, because I have to teach tomorrow. I have to go back to campus. Okay. Pardon? Oh, there, Gabriella. Yes, yes, our student. Yes, her English is excellent too. Okay, and before we close the session, I would like to apologize if there is any mistakes or mishaps that I've been doing while conducting the training. And thank you again for the opportunity, everyone. Thank you.